Hello, everyone. Welcome to today's analysis where we're going to crack an absolutely fantastic HOTS puzzle together. You know the ones, higher order thinking skills. These are those exact problems that seem, honestly, completely designed to confuse you. But by the end of our session today, you're going to see just how elegantly they can be unraveled. We are taking a brilliant puzzle straight from the source material and dissecting it, step by step. Okay, let's dive into this. Our ultimate mystery today revolves around one seemingly simple question. How do we find the exact length and breadth of a mystery rectangle? See, the source problem doesn't just hand us these numbers. Nope. Instead, it tangles them up in this wild web of fractions, comparisons, and a neighboring square. Our job today? We're going to play detective and figure out those exact dimensions. So, here's our game plan. We're going to break this down into 4 easy, bite-sized steps. The problem and clues, mystery of the perimeter, building the equation, and finally, the final solution.
Step 1. The problem and clues. Investigating the crime scene of our math puzzle.
Now, what's really interesting about this setup is how we have to organize our clues right from the start. We're looking at knowns versus unknowns. For our solid absolute facts, we have the square. The problem explicitly gives us its perimeter as exactly 40 meters. We can completely bank on that. But for our unknowns, well, we have the rectangle. We literally have no idea what its length is, so we mathematically assume it's our variable x. But the problem actually gives us a beautiful little breadcrumb for the breadth. It tells us the breadth is 1/3 of the length. So if the length is x, the breadth naturally becomes x over 3. Moving on to part 2, mystery of the perimeter. Decoding the English sentence into pure mathematics. All right. In the source problem, there's this one sentence that honestly looks like a total roadblock. I'm going to read it exactly as it appears. The perimeter of a rectangle is 2.4 meters less than 2/5 of the perimeter of a square. I know, right? It sounds like a massive wall of confusing text. But validate this for yourself. This sentence is actually our biggest, most valuable clue. It's the literal bridge between our known square and our completely unknown rectangle.
So let's walk through that exact calculation together, taking it just one step at a time to make this complex fraction super simple. Step 1, we need 2/5 of the square's perimeter. Well, we already know the square's perimeter is 40, so 2/5 multiplied by 40, that gives us 16. Easy. Step 2, the text said the rectangle's perimeter is 2.4 meters less than that result. So we simply take our 16, subtract 2.4, and that equals 13.6 meters.
Boom, 13.6 meters. Honestly, this is a major breakthrough in our case right here. We've successfully uncovered the actual perimeter of the mystery rectangle. We aren't just relying on floating variables anymore. We finally have a solid hard number to anchor our investigation.
Step 3, building the equation. Translating our clues into an algebraic formula.
Before we build the actual equation, let's just do a super quick review of the basic formula for the perimeter of a rectangle. It's simply 2 multiplied by the sum of the length plus the breadth, or as we usually see it written, 2 times L plus B. Just picture what a rectangle looks like in your head. It has 2 equal lengths on opposite sides and 2 equal breadths on the other sides. That is exactly where that 2 on the outside of the bracket comes from. Okay, let's see how this builds step by step. We're going to plug our variables into that formula to get 2 times x plus x over 3. And we set all of that equal to our hard-earned value, 13.6. Now watch how the messy algebra simplifies here. Inside the brackets, we find a common denominator of 3 for the x values, which gives us 3x plus x over 3. And that is just 4x over 3. Then we multiply that by the 2 waiting right outside the bracket, and suddenly it becomes a very neat, very tidy 8x over 3. So our clean working equation is 8x over 3 equals 13.6. And finally, part 4, the final solution. Capturing our culprits, length and breadth. We are in the home stretch now. Let's follow the logical flow of moving these numbers across the equal sign to get x completely alone. Step 1, we multiply both sides by 3 just to get rid of that pesky denominator. That gives us 8x equals 13.6 times 3. Step 2, calculate that right-hand side. 13.6 times 3 is exactly 40.8. So now we're looking at 8x equals 40.8. Step 3, to isolate x, we just divide by 8, which means x equals 40.8 divided by 8. So the crucial point here is 5.1 meters. When you divide 40.8 by 8, you get exactly 5.1. Remember back in step 1, we assumed x was the length of our rectangle? Well, that means we have successfully unmasked the true length. It is absolutely exactly 5.1 meters.
But wait, hold on. We can't pack up our detective kit just yet. We still have to find the breadth. Let's look back at our very first set of clues. We established way back then that the breadth is 1/3 of the length, right? Represented as x over 3. So all we have to do is plug our newly discovered x value directly into that slot. We substitute the variable with our hard number, 5.1 divided by 3.
And that gives us 1.7 meters. Our final breadth is exactly 1.7 meters. The puzzle is completely solved. What started as this incredibly messy paragraph of strange comparisons and missing information has been perfectly unraveled through calm, logical steps into precise, undeniable measurements. You know, I think this brilliantly illustrates that no matter how complex a problem seems at first glance, breaking it down into knowns and unknowns is the ultimate key. So I'll leave you with this thought. What other complex problems in your life can be solved by simply finding X? Seriously, think about it. When you face a daunting challenge, can you gather your known facts, define exactly what's missing, and just take it one logical step at a time? Apply this detective mindset, and you might be really surprised by what you can solve. Thank you so much for joining today's analysis. Keep questioning, keep breaking things down, and keep learning.